Word segmentation in Asian languages, including Chinese, Korean, and Japanese, is a challenging task due to the lack of explicit word boundary delimiters. This paper provides a comprehensive overview of various approaches to word segmentation in these languages, highlighting the significance of this task as the initial step for many NLP tasks. For Korean, the authors discuss the challenges arising from the high level of sparsity in Korean phrases and sentences. To address this issue, they introduce a dependency grammar for parsing tasks, incorporating various dependency constraints to overcome drawbacks such as incorrect dependency relations. For Chinese, the authors discuss statistical dependency parsing and a hybrid form of dependency parsing, emphasizing the importance of considering linguistic features to improve accuracy. Japanese word segmentation is also discussed, highlighting the role of linguistic features and statistical models in achieving high accuracy. The study presented in this paper focuses on resolving ambiguities in dependency parsing for Korean sentences using a statistical dependency parsing method. The parser selects a tree among all parses of a Korean sentence, utilizing simple constraints to reflect the syntactic characteristics of Korean. The parsing model's parameters are estimated using lexical dependency probability, with linear interpolation and backoff smoothing employed to estimate the parameter. Experiments conducted using the dependency-tagged KAIST treebank show the parser's high arc-based FM measure on both training and testing data. The results are compared to 4 other models, with the proposed model outperforming them on the testing set. The study also explores a transition-based BILSTM parser for parsing at the JMO letter level, highlighting the importance of considering the structural and syntactic characteristics of Korean in dependency parsing. Limitations of the proposed model are noted, including its performance on the training set, and future work is suggested to improve the model's performance. The proposed approach, Korean Net, introduces a novel JMO-based architecture for parsing Korean diagrams, enhancing dependency parsing accuracy. This method leverages a BILSTM model that extracts JMO letters from Korean characters using Unicode decomposition, calculating Unicode values for head, vowel, and tail consonant, and applying the tanh function to create new representations. These representations are concatenated with character-level lookup embeddings and fed into a BILSTM network trained end-to-end using a max margin objective. The implementation utilizes a publicly available Korean treebank, demonstrating the benefits of JMO letters, including implications of tense and phonetic elements. Figure 2 shows Korean Net outperforming other parsers, achieving the highest test UAS of 95.17 and test LAS of 92.31. The parser is compared to 5 other parsers, with Korean Net uniquely utilizing JMO features. A comparison of various Korean language parsers is presented in Figure 5, evaluating feature representations, pre-trained feature embeddings, and POS tag implementations. The study highlights the limitations of statistical approaches for POS disambiguation in agglutinative languages like Korean. To address these limitations, a hybrid method combining statistical and rule-based approaches is proposed, integrating a morpheme dictionary to enhance morpheme identification accuracy. The hybrid model includes morpheme segmentation, recovering original morphemes from spelling changes, and morphotactic modeling. Morpheme segmentation utilizes a tree-structured index for fast matching, while morphotactic modeling employs POS tags and morphotactic adjacency symbols. The study demonstrates a potential solution to overcome the challenges posed by agglutinative languages in POS disambiguation, tightly coupling the hybrid model with generalized unknown morpheme guessing techniques. This research paper discusses a hybrid tagging model for part-of-speech (POS) disambiguation in Korean, which consists of a morphological analyzer with unknown morpheme handler, a statistical POS tagger, and a rule-based error corrector. The model utilizes a morpheme dictionary to encode the full hierarchy of POS tags and morphotactic adjacency symbols for each morpheme, allowing for the identification and recovery of unknown morphemes. The statistical POS tagger employs the Viterbi algorithm to search for the optimal tag sequence, while the rule-based error corrector uses a transformer architecture to correct mistagged morphemes by consulting lexical patterns and contextual information. The performance of the statistical tagger is evaluated on 3 document sets with progressively degraded versions of the tagging mechanism, demonstrating a significant drop in performance between versions 1, 2, and 3. This verifies the effectiveness of the unknown morpheme segmentation and guessing techniques. The hybrid tagger's performance is also tested, with version 1 incorporating unknown morpheme segmentation, guessing, and rule-based error correction, and version 2 omitting a posteriori error correction rules. The results show a mild performance drop between version 1 and version 2, indicating that the statistical tagger alone achieves state-of-the-art performance for tagging Korean morphemes. The paper also compares the proposed hybrid model with previous models, highlighting its advantages and disadvantages. The model's high recall and precision scores for various POS tags demonstrate its effectiveness in handling unknown morphemes. Each of the three methods discussed has its own strengths and weaknesses, with the hybrid hidden Markov model proposed by Gary et al. Showing the highest accuracy. In addition, the paper discusses the challenges of Chinese word segmentation, CWS, due to the lack of word delimiters and the complexity of Chinese characters. It highlights two major difficulties in CWS: ambiguity and out-of-vocabulary words. Character-based approaches, such as conditional random field, CRF, and maximum entropy modeling, MEM, were dominant solutions for CWS in the past but have limitations, such as the inability to handle unknown characters and the need for explicit wordhood information. Recent approaches incorporating neural network (NN) techniques have proven to be powerful in dealing with CWS. However, NN architectures can provide accurate models but lack explicit wordhood information. The wordhood memory module, WMSEG, proposed by Tian et al., combines a neural CWS approach with a wordhood memory module, which provides more wordhood information of the context. The WMSEG architecture consists of a text encoder, memory networks, and a decoder. The input sentence is first encoded, and then NGRAMS are extracted and passed to the memory networks along with wordhood information from a lexicon. The output is then passed to the decoder to predict segmentation labels. The innovative part of WMSEG is the wordhood memory networks, which model pairwise knowledge and offer valuable information between segmented contexts and their meanings. The model also introduces flexibility to integrate various encoders and decoders. Experimental results on SIGHAN 2005 and CTB6 datasets show that WMSEG outperforms other models, especially when using the wordhood memory module. The results indicate that the overall performance is improved when adopting the wordhood memory module, with higher scores on MSR, PKU, AS, CITIU, and CTB6 benchmark datasets. The WMSEG model uses a combination of BILSTM, BERT, and Zen encoders and softmax and CRF decoders. The experimental results show that the model achieves state-of-the-art performance on CWS tasks, especially when using the wordhood memory module. The results also indicate that the model can handle out-of-vocabulary words and provide more accurate segmentation labels. Word segmentation is a pivotal task in natural language processing, particularly for languages such as Chinese and Japanese where word boundaries are not explicitly marked. The authors discuss various approaches to word segmentation, including the hidden Markov model, HM, and neural network-based methods. The HM is a stochastic algorithm that determines word boundaries based on the probability of word sequences. However, it has limitations, such as requiring a large word lexicon and struggling with out-of-vocabulary words. To address these issues, researchers have proposed hybrid methods that combine HM with character-level information, such as character tagging and word-level Markov models. One such hybrid approach is presented by Nakagawa et al., which uses a combination of HM and character-level information to improve word segmentation accuracy. This approach uses a lattice structure to represent word candidates and their corresponding probabilities. The lattice is constructed by labeling words with four main types of tags: beginning of a word, B, middle of a word, I, end of a word, E, and itself is a word, S. Neural network-based approaches have been shown to achieve state-of-the-art accuracy in word segmentation tasks. Kitagawa and Kamachi proposed a long short-term memory (LSTM) network for Japanese word segmentation, which incorporates character type embeddings, character-based NGRAM embeddings, and a word dictionary. The LSTM architecture is designed to capture long-distance information and optimize performance. Experimental results comparing the performance of different word segmentation methods are presented, including HMM, hybrid HMM character-level methods, and LSTM-BASED approaches. The results show that the LSTM-BASED approach achieves the highest F1 score of 98.42. The authors conclude that each method has its pros and cons, with HM being easy to understand but limited in its ability to determine word boundaries, and neural network-based approaches achieving higher accuracy but requiring more complex training. The paper also discusses the application of these models in English processing, specifically in handwriting recognition, where spaces between words are not clear. The Chinese word segmentation method can help distinguish the boundaries of English words, demonstrating the universality of many mathematical methods of language processing. A comprehensive evaluation of word segmentation models on a wide range of languages is presented, including Asian languages, Western and Eastern European languages, South American languages, and Middle Eastern languages. The evaluation results show that the proposed method outperforms UD-pipe in most datasets, with significant improvements observed in languages such as Arabic, Hebrew, and Hindi. The authors emphasize the importance of word segmentation in natural language processing, as it directly impacts parsing accuracy. They suggest that future work could involve exploring newer techniques for handling a broader array of Asian languages and analyzing the advantages and disadvantages of the new method compared to other methods discussed in the survey. The paper concludes by summarizing the contributions of each team member, with Matthew focusing on Korean word segmentation models and related work, Chen focusing on Japanese word segmentation models and future work, and Yexin focusing on Chinese word segmentation models and the significance of word segmentation in natural language processing. Here is the combined summary of pages 17 and 18. Word segmentation is a fundamental task in natural language processing, and its complexity varies across languages. The authors conduct an exhaustive review of existing research on word segmentation in Chinese, Japanese, and Korean, highlighting the diverse approaches employed to tackle this task. Statistical models, machine learning algorithms, and rule-based methods have been utilized to segment words in these languages. In the context of Chinese word segmentation, maximum entropy modeling, conditional random fields, and word-hood memory networks have been employed. For Japanese word segmentation, long short-term memory networks and hidden Markov models have been utilized. Korean word segmentation has been addressed using syllable pattern-based segmentation, hybrid part-of-speech tagging, and tied sequence-to-sequence multitask models. The authors emphasize the importance of considering linguistic features unique to each language, such as Chinese characters, Japanese kanji, and Korean morphological analysis. Word segmentation is a crucial step in various applications, including machine translation, sentiment analysis, and text summarization. However, languages with complex scripts, like Chinese and Japanese, pose significant challenges, requiring specialized techniques for word segmentation. The comprehensive review of existing research sets the stage for the author's proposed approach, which is not explicitly stated in these 2 pages. However, the emphasis on linguistic features specific to each language suggests that the authors are poised to present a novel approach that addresses the limitations of previous studies.